Today we are going to learn how to name ionic compounds. So we're going to take what we learned with building ionic compounds and apply it a little bit to figure out what we would actually call it. So we have some instructions over here, and then we have 3 examples. So our first example is Li2S. So the first step is to write the first element's name, which coincidentally is always the metal ion, and the metal ion always has a positive oxidation state. So we are going to write Li out. Li is lithium. Next step, we are going to write the second element's name, changing the ending to "ide." The second element would always have a negative oxidation state, meaning it took the electrons that the first ion gave up. So S stands for sulfur. We need to change the ending to IDE, so we would call it sulfide. Sometimes there's a question of what letters get dropped in to add the IDE, and basically the common elements, it just becomes much more intuitive as you hear them over again. The ones that you are unsure of, drop a couple and add an "ide," and I will get it. I won't ever take points off as long as you remember to add the IDE, is what you're wondering. All right. So we have an exception to this rule down here, and we're going to get to that in a minute. The next element, the next compound we're going to name is FeO. So same thing, we are going to name Fe. It's iron. But iron is one of those transition metals. It can have a variable oxidation state. It can either be +2 or +3. So when you go to name it, you need to state what its oxidation state is. And to do that, you have to figure it out. So to figure it out, oxygen falls in column 16, so it always has a -2 oxidation state. Oxygen will never ever vary. It's always going to be -2. Knowing that this overall compound has to have a charge of 0 and that oxygen is -2, iron must be +2, as those charges cancel each other out to be 0. So we are going to write in parentheses iron 2, as this ion is specifically the iron 2 ion. It is not the iron 3 ion. And then we are going to name oxygen, and we're going to change the ending to "ide," so it becomes oxide. So this element's called iron 2 oxide. The last variation for naming an ionic compound is when there is a polyatomic ion present. And that is when you do not change the ending. A polyatomic ion is always just called whatever it's called. So let's name the first part of it. That part doesn't change. Potassium does not have a variable oxidation number. It is always the same number. So we do not need to put it in Roman numerals. We can just call K potassium. PO4, if you look on your polyatomic ion chart, it is the bottom half of your ion sheet. And look in alphabetical order, you will find PO4, and it writes what its charge is, but it's not written as a compound here. But PO4 is always called phosphate, so we will not change the ending of that, and we will just call that phosphate. So K3PO4 is called potassium phosphate. And those are the 3 different variations for naming ionic compounds. This one's simple. Lithium doesn't have multiple oxidation states, so you just call it lithium sulfide by changing the ending to IDE. Iron has multiple oxidation states, so you have to state what it is. Don't forget to do that. And we will change the ending to IDE. And lastly, if you have a polyatomic ion present, you would never change the ending of that. And the polyatomic ion, 98% of the time, is always going to be the last portion of the ionic compound. So if you're unsure of how to recognize a polyatomic ion, you will have more than 2 capital letters, because that means you have more than 2 different types of elements present. And usually the last bunch, or the last two capital letters, including the subscripts, are the polyatomic ion. In both of these other examples, we only had two capital letters, as well as the endings IDE. So that's a good way of trying to recognize polyatomic ions until they become more familiar to you. All right, thank you.